Hello everyone, welcome to all in YourPedia. My name is Manish Singh and now I am going to discuss with you something about additive manufacturing process, correct. So, before going to start this session, first of all I am telling you this session is very important for those students who are preparing for GATE 2024, ISRO 2023 and along with this those students who are planning to pursue their career on additive manufacturing after BTech. Yes or no? So, this session is very important for you guys, because from this session you can learn how to define additive manufacturing process, what are the types of additive manufacturing process, what type of materials used, where we can use this technology to produce component for which types of applications, correct. So, this session is very important. So, let us see one by one. So, in this session I will proceed this session like this. So, first of all I am telling you introduction of additive manufacturing, how to define and what are the basic components of additive manufacturing process, and after that additive manufacturing steps for producing any component, what steps we follow, correct, in additive manufacturing process, correct. And after that what is the difference between additive manufacturing and subtractive manufacturing, correct. This is the very important key point. And after that classification, detailed classification of additive manufacturing, then material used in the additive manufacturing process and the application of those additive manufacturing processes, because we have several processes, correct, and some important questions which are already asked in the previous exams and may also ask in the upcoming exams, correct. So, let us see one by one. First, that is how to define additive manufacturing process. So, here I am going to define on the basis of a definition given by ASTM, that is American Standard for Testing of Materials, correct. So, according to ASTM standard, additive manufacturing is defined as a process by which digital 3D design data is used to build up a component by layer deposition, yes or no. So, this is the basic definition of additive manufacturing process, and this definition is broadly applicable for all kind of materials, whether it is plastic or ceramics or metals or etc., correct. So, this definition is very broad definition, correct, which can be applied for any kind of materials. So, basic principle of additive manufacturing is nothing but, in this first we make a model with the help of 3D CAD softwares, yes or no, like Creo or SolidWorks, Solid Edge, etc., correct. So, with the help of these softwares we can make a 3D model, and after using these 3D models with these 3D design data we can produce the component directly, correct. So, this is the basic principle of any additive manufacturing process. And now let us see, any additive manufacturing consists of these three things. These are the very important things, like if we talk about motion system, correct. Motion system is very important part of this additive manufacturing process, and after that heat source, correct, and feedstock. Now, if we talk about motion system, and obviously you can see, for suppose if you want to make any component, suppose if you want any component with help of this 3D printing or 3D additive manufacturing. So, obviously we have a platform, correct, we have a platform, you can see here, this is we have our platform, correct, this is 2D platform. If I define its axis system, then obviously we can say, let us say suppose this is x axis and this is y axis, correct, and similarly here we have some source of power supply, and this source of power supply can move along the z axis, correct. So, manufacturing of any 3D component, we need to provide motion of this work table along the x and y axis, and similarly we also need to provide motion of this torch or a power source which can move over the surface of xy, correct. Then after that we can provide obtain the 3-dimensional object, correct. So, motion system, heat source. Now, if we talk about heat source, so various heat sources are already developed or researched for producing any 3-dimensional part with the help of this additive manufacturing. And if we talk about some source, then whether we can use laser beam or we can use electron beam, and so nowadays we can also use as a welding arc for the heat source, and sometimes ultraviolet rays are also used for curing purpose, correct. So here we use many heat source, and after that feedstock. Now, if we talk about feedstock, so any 3D object, obviously we know that it is made up of a material, yes or no. So we need to provide a proper feed material, correct. It is either it is in the liquid form, it is in the if we talk about solids, then it may be it is present in the form of powder or a wire form, yes or no. So these are called as feed material, and for feeding of these materials we need to provide a feeding mechanism, yes or no, correct. So feedstock is nothing but it is the material which is used for producing any 3D component, and for feeding of these materials we need to provide a feedstock mechanism so that we can provide the material. Is it clear? So this is all about introduction of this additive manufacturing process. Okay, now let us see what are the steps we need to follow for producing any components, correct. So our first step is, that is CAD modeling, correct. That is CAD modeling. Let us say, suppose if you want to make a component like this, suppose we need to produce a component like this. So what we will do, let us say this is a cube and we need to manufacture this, correct. So first we need to make its CAD model, correct, and after preparation of CAD model by using several CAD softwares, obviously we can make it, and after that we need to slice it. Slicing means we cut this object in a various and several layers, yes or no, like this. This is called as slicing. It can also be drawn like this. This is one slice, it has some thickness, and this is another slice. Correct, and similarly the whole object may sliced, yes or no, layer by layer. This is called as slicing, and this is again very important steps for any additive manufacturing technology. Okay, now after slicing we need to create a file which is called STL file, STL dot file. This is very important. After slicing we convert this CAD model into a STL file, and this STL file is transferred to the 3D printer, correct. 3D printer is a machine which is use this data to produce a component. Is it clear? After transferring of these data, 3D layer over layer deposition takes place, yes or no, correct. When you transfer this data to the machine, then your 3D printer works on these data, correct, and after deposition, correct, after transfer you just deposit the material layer by layer, and after depositing when you get the final objects, so some finishing operation may also perform. Is it clear? The removal of objects from the substrate. Obviously what is substrate? Obviously here we have a build platform, over we can deposit our object. So this is our platform. On this platform we make a correct. Okay, so okay, let's say, let's suppose we have this is a weld platform, this which is called as substrate. This is called as substrate, and over the substrate we make our 3-dimensional object like this. We deposit our object like this, correct. So this is our final product. This is our final product which can be deposited by 3D printer, and this is our substrate, or we can say this is a weld platform. So after deposition of this component, we need to separate this object from the substrate, yes or no? And after separation we again perform several finishing operation, yes or no, several finishing operations, so that we can get the exact shape of the component with proper surface finish and proper surface integrity, correct? Okay, so this is the detailed steps which can be followed for producing any three-dimensional objects. Okay, next question, what is the difference between additive manufacturing and subtractive manufacturing, correct? So, this is the very important question. Sometimes this occurs in the mind, why we use additive manufacturing, why not subtractive manufacturing process, or if several conventional manufacturing processes are already there, so why we develop these processes. So, these are the few questions. Out of this we need to find what are the correct answer of these questions, correct? So, let us see, if we talk about subtractive manufacturing, so you can see, suppose this is our final product, correct? This is our final product, we need to produce this. Then how we can produce? With the help of conventional subtractive machine, subtractive process. So, this is the raw material, yes or no? This is raw material, and in this raw material, with the help of these machining tools, we can remove some extra material, yes or no? Like this, you just remove this extra material, and once you remove this extra material, then you can get a shape like this, and after that you just remove this portion also, then this is your final product, correct? So, what we will do in the subtractive manufacturing process, we remove extra material from already we have a raw material, correct? Whatever we have raw material, from that raw material we just remove the extra material, then we can get our final product. So, this is subtractive manufacturing process. Now, if we talk about additive manufacturing process, then obviously this is our substrate, this is our substrate, yes or no? And by using 3D printer, we can deposit the object layer over layer like this, correct? So, after deposition of these layers, we can get this final product, yes or no, correct? So, this is called as additive manufacturing process. So, if we talk about the basic difference between these two processes, in this the manufacturing of final product takes place by removal extra material. So, material wastage, huge amount of material wastage takes place, yes or no? But in this case, since the material, the object is produced by depositing layer over layer, correct, then the wastage of material is very less. This is one of the biggest advantage of this technology. And one more thing, if we talk about, then sometimes when we have very hard superalloys which are very poor in machining, correct. So, it is very difficult to machine that materials for making a component. So, what we will do, correct. So, in that case machining is not suitable process, correct. So, whenever we have situation like this, then we, with the help of this additive manufacturing, we can minimize or overcome this difficulties, and we can make the component, yes or no. So, this is one of the biggest advantage. And now let us see some more advantages. And additive manufacturing involves editing a layer of materials to create an object, 3D object, but in subtractive manufacturing removes material from an object, correct. From the raw material we just remove the extra material in the form of chips, then you can get the final product. Next, processing includes 3D printing, correct. Processing includes 3D printing directly from 3D design data, but in this case the processing involves manual or traditional machining or CNC machining for removal of excess material, correct. Use computer and specialized 3D printing equipments to create product in additive manufacturing. But when we talk about subtractive manufacturing, then uses computer and robotics to assist standard machining process which are already developed earlier, yes or no. जो पहले से process develop कर ली गई हैं, उन process को computer के साथ we just integrate the these processes with the help of computer and perform several cutting operations, yes or no, like turning, drilling, milling and etc. We have several different metal cutting processes, yes or no. And now let us see another the difference, that is the layer of often leaves a slight stepped or rough surfaces which needs to finish post printed by sanding or blowing. Means when, let us see, when you manufacture object with the help of 3D printer, then when we see this object in a micron level, then it may produce like this. Suppose this is our first layer, and if we talk about another layer, then might be it will produce, it will make some step like this. So, you can see here, if we see, okay, once again you can see here, this is our first layer, correct, and when we make another layer over this, then little large or little less layer may produce, correct, less like this, like this. So, we need to remove this extra material, this stepped material. So, for this we need to perform surface finish operations, correct, in 3D printing, correct. But in case of a machining process, a variety of surface finish operations, variety of surface finish processes are already there to machine the component, include with a smooth surface finish, correct. And now integrate and hollow objects can easily be built with the help of 3D printer. This is one of the biggest advantage of any additive manufacturing process, that is very complex object can be easily produced, very complex object can be easily produced. But this process is suited for manufacturing voluminous items and parts, especially in metals, correct. So, this technology, subtractive manufacturing process, is basically used for manufacturing metallic parts, and obviously here we can produce a very good surface finish, yes or no. But here we have some limitations for, especially for making a integrate complex objects, correct, and especially in those objects where we have some projection, we have some hollow cavities, zigzag cavities, which cannot, which is very difficult to produce, correct. Obviously with the help of some unconventional process we can develop, we can make it, correct, but its costing is very high, okay. Next, depending upon the size of the object, 3D printing can be slow process, correct. This is one of the limitation of additive manufacturing process, that is production rate is slow, but nowadays the researchers may develop some processes which can manufacture component at a very high speed, like wire and arc additive manufacturing is one of them, which whose production rate is and deposition rate is very high, correct. And the obviously the machining process is relatively fast process, correct. Next you can see here, software is involved directly linked to the design to the 3D printer of a machine parts. Is it necessary, correct, but in this CNC machines required to operate the mill of machine and oversees the production. However, new automatic software means that programming machine executes code is no longer needed. So, you can see here in this the special, in this we have several softwares which directly inbuilt in the machine, and they, once you just make a 3D CAD model, slice it, and you just produce a STL file and transfer to the machine, then machine automatically work entire process, correct, perform entire process. But in case of CNC machine, operators required to operate that machine, although the codes are available, but along with these codes, operators also needs to operate that one, but in case of 3D printing it is not necessary, correct. Overall 3D printing is a fairly cheap process, and non-additive manufacturing, that is subtractive manufacturing process, is a little costly process, correct. Okay. So, after detailed difference between them, here we see the detailed classification of the additive manufacturing process, and according to the American Society for Testing and Materials International Committee, F42 classifies additive manufacturing technologies into 7 categories, correct. According to ASTM, we have 7 categories of additive manufacturing process, and out of them the first one, that is wet photopolymerization process, next one that is binder jetting, next material jetting, then material extrusion, direct energy deposition, powder bed fusion and sheet lamination. These are the different 7 category of additive manufacturing process which is defined by the American Society for Testing of Material, that is ASTM. Is that clear? Okay. So, let us see one by one. Now, first if we talk about wet polymerization process, then obviously in this process we use as a polymer, correct, wet polymer. And now you can see here, this is the build platform. You can see, first we see how this process can be performed. So, this is build platform, yes or no, and this is the resin which is solidified according to the shape of the object, yes or no, correct. So, first what we need to do, initially it is positioned here and over the substrate we just provide a resin, and that resin according to the shape of the object we just cured with the help of ultraviolet rays, correct, UV rays or laser light, correct. With the help of this we just cured in a certain region. Suppose if you need to provide, so let us say if we talk about the production start from here, not from top, it start from this surface, yes or no. So, initially it is positioned somewhere here, then over this we just deposit one layer of this material, How we can deposit? You just see here, initially okay, initially you can see here, yes, initially this platform is situated somewhere here, correct. Initially this platform is situated somewhere here, yes or no, and over this platform here we have polymers, यहाँ पे क्या होगा, here we have a resin, correct. Then according to the shape this power source cured that polymer, yes or no. So, the polymer is cured over this surface like this. This is first layer, yes or no, according to the size, and after that this stands platform moves in the downward direction. Then again over the layer the polymer may provide, and after polymer providing we just cure again. So, like this you can cure layer by layer the polymers, then you can get our final product. So, this is called as wet polymerization process, and in this wet polymerization process especially we use wet polymer, correct. In this we use wet polymers or liquid polymer resin, out of which the model is constructed layer by layer, correct. And ultraviolet, you can see here, ultraviolet light is used to cure polymers, yes or no, to provide hard surface, because here we have liquid resin, correct, because here we have raw material in the form of liquid polymer resin, correct, and we need to cure that polymer. That is why after curing you can get the hard surface, and this curing process is performed by using UV light, yes or no, and after curing you can get hard resin, correct, which is your final product, correct. So, now let us see what are the steps we need to perform for making any component with the help of this wet polymerization process. So, first one, that is the build platform is lowered from the top of the resin wet downward by the layer thickness, correct. Means already I have discussed with you, initially your platform is positioned here, and according to the size of the object it can lowered in the downward direction, yes or no, and a UV light cures the resin layer by layer, correct. After let us say suppose you have a platform at this position, and over the platform you have some resin, and that resin is cured by using ultraviolet rays, correct, and after curing you just move this platform in the downward direction, and again you perform same procedure, you just move your light source, UV light source according to the shape of the object, and then again curing perform, correct, and this procedure is repeated till your final object is manufactured, correct. Some machines use blades. After deposition, what will we need to do? After deposition, we need to separate this object from this, and for this separation sometimes we use blades or something other tools to separate it, correct. And after completion of that, vat is drained of the resin. After completion of this, we just remove this liquid resin, correct, and you can get the final product, yes or no. So this is the all about vat polymerization process. And now let us see binder jetting process. This is another class of additive manufacturing process, that is binder jetting. In the binder jetting process uses two materials, that is powder, this is our parent material, powder, this is our parent material, and along with this powder we use binder, yes or no, we use binder. So let us say, suppose you need to make a component through this process, then what we will do here, this is our machine, this is schematic diagram of this machine, correct. And in this the binder act as a adhesive. One more thing, the binder act as a adhesive, means it act as a adhesive to bind the parent powder material, correct. And the binder is generally present in the form of liquid, is it clear? Binder is generally present in the form of liquid, and the raw material is present in the form of powder. So what we will do in this process, let us see, suppose we have this is our platform, correct. So initially what we will need to do, when your platform is situated here, then over this surface we just provide the powder, yes or no. And once you provide the powder, then with the help of this liquid binder you just pass, means so you can see here, suppose this is our substrate, and over the substrate first we provide through powder throughout the surface of the substrate, correct. We just spread the powder throughout the surface of the substrate, correct. And after spreading, what will we need to do, let us say suppose this is a jet of the binder, then according to the shape of the object you just move this head of this binder which provides the liquid binder, yes or no. And once you provide the liquid binder, then it gets stick, these particles of the powder stick to each other, yes or no, and you can get a solid surface, correct. And once first layer is deposited, then you just move this weld platform in the downward direction, then again we spread the powder over the surface of the surface of the platform, yes or no, and again we just provide the liquid binder over the surface, correct. So again where we provide liquid binder, then those powder particles can get stick to each other, yes or no, and they make a solid surfaces, and this process is performed repeatedly performed till you can get the final object, yes or no. So obviously in this binder jetting process, the powder material is spread over the build platform, yes or no, this is a build platform, yes or no, this is build platform. After that the print head deposits the binder additives on the top of the powder where required, yes or no, according to our requirement we just provide the liquid binder. The build platform is lowered by models layer thickness, correct. After first layer of deposition you just lower the build platform, and again we provide powder over the surface, and again we provide the binding agent, and after providing binding agent again it lowers, and again same procedure is followed, correct. Another layer of powder is spread over the previous layer, the object is formed where the powder is bounded to the liquid obviously, and remaining powder is loose form and we can remove it, correct. Unbound powder remains in the position surrounding the object. The process is repeated until the entire object has been made, correct. So basically these processes are used for plastics, correct, for making models, is it clear? Okay, now let us say material jetting process. This is another class of additive manufacturing process, and in the material jetting process you can see here, in this we create an object by in the similar manner of two dimensional link jet printer, correct. It is based on the principle of link jet printer. Material is jetted onto the built platform using either a continuous drop on demand, either the material can be provided either continuously or it depends upon the drop on demands, means जहाँ पे material की requirement होगी वहाँ आप material provide करोगे and rest of the part you cannot provide the material. Is it clear? So material is provided on the basis of their requirement. And now material is deposited from a nozzle which is moves horizontally across the weld platform. So you can see here, this is the nozzle, this is the nozzle which is moved along the horizontal direction like this and like this, yes or no, and the material correct, which moves horizontally across the weld platform, and the material layer are then cured or hardened by using UV light. Again we use UV light as a heat source to cure, and you can see, and this platform can move downward direction, yes or no. So vertical motion is provided to the weld platform and the horizontal motion is provided to the nozzle itself, and again here we use ultraviolet rays to cure the binder, yes or no. Now if we see what are the steps we need to perform, so the printer head is positioned above the platform, yes, you can see here this printer head which is provided over the build platform, and the droplets of the materials are deposited from the printer head onto the surface where required using either thermal or piezoelectric method, yes or no. So according to the requirement, with the help of these nozzles, we can provide the material which is, you can see here these nozzles are connected with these tanks, yes or no, as it is very much similar to printer, yes or no, inkjet printer. Inkjet printers में क्या होता है, you just take a ink from these tanks and provide according to the requirement, correct. Okay, after that droplets of the material solidify and make up the first layer, further layer are built up as before on the top of the previous. So this process is very much similar to previous one here, except in this we provide build material in the form of this form, correct, in the form of this, these nozzles are in the principle of inkjet printer, yes or no. Okay. Layer are allowed to cool after deposition, layer are allowed to cool or cured by UV light. Post processing includes removal of support materials. So whatever here we have support material which can be removed after completion of layer deposition, correct. So this is all about material jetting process. Next one, material extrusion process, correct. So as we know that extrusion is nothing but when the material is pushed against the die, then you can get the desired shape. This is the principle of extrusion. And now in this material extrusion process, you can see here we have material spool, yes or no. This is a material spool, and this material spool is passes through this nozzle which is heated nozzle. Here we have a heating element, yes or no. In this we have a heating element, is it clear? You can see here this is a heating nozzle. So when you pass this material, then because of this heating, when it contact with the heating nozzle, then it get melted, yes or no, it get melted, and that melted material is deposited over the build platform, yes or no. You just deposit, you just melt the material and deposit according to the requirement, yes or no. So this is called as FDM process, that is fused deposit method, correct, fused deposition modeling, is it clear? So this is very simple process, correct. So again you have a build platform, a nozzle, and obviously sometimes we provide this nozzle in the horizontal plane, we provide the motion, correct, in the horizontal plane along the x and y axis both, correct. Okay, and similarly here we have a build platform which can move in the vertical direction, correct. Okay, fused deposit modeling is a common material extrusion process. Material is drawn through a nozzle where it is heated and then deposited layer by layer. The nozzle can move horizontally and platform moves upward and downward vertically, correct. Nozzle, obviously nozzle is provided to the horizontal motion along x and y plane, x and y axis, correct, and similarly the build platform is provided to the vertical motion either up or down, correct. And after that you can see here the nozzle can move horizontally and platform moves up and down vertically vertical after each new layer is deposited. Note, you can see here, this is very important point, commonly used technique used as the many inexpensive domestic and hobby 3D printers, correct. This is extensively used for either making domestic parts like toys or some other parts and hobby 3D printers. It used as a hobby 3D printers, correct. Okay, now if we talk about the steps, what steps we follow on this process, then first layer is built up as a nozzle, deposited material where required onto the cross sectional area of the first objects. So listen, in all the additive manufacturing process, the processes remain same, correct. We need to first we need to make CAD model, then slice, then convert STL file, then that STL file is transferred to the 3D printer and we just run the machine. And once you run the machine, and then according to your 3D codes, the machine can move, machine can work, yes or no, correct. And now the following layers are added on the top of the previous layer. Obviously first we make a first layer, and after deposition of first layer we just move the build platform in the downward direction, then again over the first layer we deposit another layer and again we move in the downward direction, and this process is repeated till the final object can be produced. Okay. So next method, in the previous methods we use plastic as a feedstock material, correct. Now we have a technology which is uses a metal as a feedstock material, correct. So this is called direct energy deposition method, that is also called as DED, direct energy deposition method. And this DED method is generally coined some more names like a laser engineered net shaping, that is called lens, direct light fabrication process, direct metal deposition process, or 3D laser cladding process, or wire and arc additive manufacturing process, correct. So here we have several direct energy deposition methods, correct. And in those methods we uses different power source and different form of metals, either in the form of powder or in the form of wire stock, feedstock wire, yes or no, correct. So a typical DED machine consists of a nozzle mounted on the multi-axis arm which deposits melted material onto the specific surface. You can see here again you have a build platform which is called as substrate, and over the substrate we need to deposit the material according to our shape of the final product, and this is the power source, either it may be a electron beam or a laser beam or a arc as a power welding arc as a power source. So many power source we use for the deposition of the material. And similarly you can see here this is a metal wire, correct. Either we use metal wire or we can use powder, metallic powder, etc., correct. So let us say suppose if we use metal wire, then obviously this metal wire is melted by using this heat source which is provided by either electron beam or laser beam or a welding arc. Then after melting, this metal is deposited layer over layer, layer over layer, and then you can get the final product, yes or no. So this is called as direct energy deposition method. And now if we talk about its steps, what are the steps which followed for making a component, that is in this 4 or 5 axis arm with nozzles moves around a fixed objects. So listen, in this technology mainly we use robots, correct. And now materials is deposited from the nozzle onto the existing surface of the object. Material is either provided in the form of wire or in the form of powder, we already told you, and the material is melted using a laser, electron beam or welding, already I have told you. In this process we use as a laser, electron beam or laser beam or a welding arc as a heat source for the deposition of the material, and further material is added layer by layer and solidifies, creating a repairing new material features on the existing objects. So this technology is used for making any new component, or we can also use as a repair work, correct. So this is all about direct energy deposition method. Now let us say another method, that is powder wet fusion method, correct, powder wet fusion method. So you can see this is again, this is a 3D printing, again we can say this is a 3D printing. 3D printing is a very common name which is used as an alternative name of additive manufacturing process, correct. Okay, so the powder bed fusion process includes the following commonly used printing techniques: direct metal laser sintering DMLS, that is direct metal laser sintering, electron beam melting, selective heat sintering, selective laser melting, that is a SLM, selective laser sintering, that is SLS. These are the few names, especially selective laser sintering, selective laser melting and electron beam melting. These are the very common names in which the extensive research is already going on, correct, and especially for 3D printing of metals, correct, 3D printing of metals. Okay, so powder bed fusion methods are either a laser or electron beam, correct. So in this method we generally use laser beam as a power source or electron beam as a power source. Similarly, electron beam melting methods require vacuum. Whenever we use electron beam melting, then vacuum is necessary. Why? Because in some medium laser electron beams may scattered. So for preventing scattering, we need to in actually you can see if we compare this electron beam melting with electron beam machining. So both are same, correct, both are same. In electron beam melting, or we can say electron beam welding, it is much convenient than electron beam machining, correct. So in electron beam melting, what we will do, we provide a closed vacuum chamber in which we have a hooper, sorry, we have a cathode ring through which we can produce electron beam, yes or no. And for controlling of electron beams, we have several electromagnets to control or to concentrate that electron beam in a particular zone, and where we need to weld it, then you just concentrate the electron beam, and because of that electron beam heat, the metal get melted, and after melting obviously it gets solidified and then you can get the joint. So this is the principle of electron beam welding process. Now if we use same manner, if we use this technology in a same manner, instead of creating a joint, we just, what we will do, we just concentrate the heat and at a certain region, and we provide this system in such a manner it can move in the xy direction. Is it clear? We just control this electron gun with the help of computer aided machine, yes or no, we just control it. So according to the requirement, your electron beam moves over the build platform, yes or no, where we provide the liquid material, sorry, where we provide the powder, metallic powder, correct. And that if after providing metallic powder, you when you pass the electron beam, then by the utilization of that heat, the powder get either sintered or it get melted. If it is melted, then this is called as selective laser melting, sorry, electron beam melting, and if it is get sintered, then this is called as electron beam sintering process, not melting. And if we talk about the basic difference between sintering and melting is, in sintering only particles may fuse to each other, yes or no. You can see here, when we talk about sintering, then let us say suppose we have a particles like this, these are the powder, metallic powder particles, yes or no. When you provide heat in such a way that only these particles may make bond like this, you can say this is called sintering. This is called sintering. Only in this region they locally melt and fuse to each other, yes or no, correct. This is called as sintering. Now if we talk about melting, then what we will do, when you heat that material above its melting temperature, obviously above the melting temperature, then each particles get melted and here we can get a liquid, yes or no, and that liquid materials get solidifies, that liquid metal get solidifies, correct, and after solidification you can get the whole enter objects like this, correct. So this is the basic difference between sintering and melting. In sintering we just heat the material in such a way that they only fuse to each other and complete melting does not takes place, yes or no. But in case of melting, we provide heat in such a way that those particles completely melted, yes or no, powder particles completely melted and then solidified to it, correct, then we can get the final object. So this is the basic difference between sintering and melting, yes or no. So I think this difference is enough for understanding selective laser melting as well as selective laser sintering, correct. Okay. So now all powder bed fusion process involves the spreading of the powder metal over the previous layer. Obviously, suppose you have one layer and you just provide the laser light, electron beam light or laser light to melt that material, yes or no. After melting, what we will need to do, again we spread the powder over the surface, over the first layer, correct, and then again we provide according to the shape of the object. Heat, we just provide the heat, and again melting takes place, and after that again we provide the again we spread the powder over the surface, and this process is continuously we perform. Okay. A hooper or a reservoir below of aside the bed provides fresh material supply. Obviously, in this you can say here we have a powder roller which provides fresh powder which can be spread over the build platform, yes or no. You can see here this is a powder rollers, and this is a new powder stock, correct. As the one layer is deposited, then it just move in the upward direction, then some powder gets like this, and with the help of this roller you just spread this powder over the whole surface somewhere here, and after spreading we just provide the heat, so we can melt and cure it, correct. So, this is the method. Okay, direct metal laser sintering DMLS is the same as the SLS, but with the use of metals and not plastic. Here we use metals, not plastic, correct, and the process sintered the powder layer by layer. Is it clear? So, this is all about powder bed fusion process, and if we see what are the steps we can perform to make any components, then once again you can see a layer typically 0.1 mm thick of the material is spread over the build platform. Obviously, when you have your build platform somewhere here, this is your build platform, yes or no. Then over this build platform we just spread powder, okay, we just spread powder somewhere here, yes or no, like this, and once you spread this powder with the help of this roller, you just provide heat, correct, for curing air or for melting. After melting, again we perform same step. A laser fuse the first layer of the first cross section of the model, a new layer of the powder is spread across the previous layer, and further layer or cross sections are fused and added over the previous layer, correct, and the process repeated until the entire model is created, correct, and loose reused powder is remain in the position, but it removed during the processing. When the complete all the layers are deposited, and after deposition you just remove that extra powder and bring your powder, correct, your object, final object, correct, from the platform. Is it clear? So, this is the detailed steps which can be performed for producing a component with the help of FBF process, sorry, powder bed fusion process, correct. Okay, next, sheet lamination. What about sheet lamination? This is very simple method. What will we need to do? And one more thing, this is also named as loom. Sheet lamination process includes ultrasonic additive manufacturing, that is UAM, and a laminated object manufactured, correct, that is called as LOM. And laminated object manufactured uses a layer by layer approach and uses paper as a material. In this we use paper as a material. So, what we need to do, we just spread the paper over the build platform, and over the paper you just provide some binder, and that binder is cured by using either laser light or ultrasonic light, yes or no, ultraviolet rays, and with the help of this we just cure it. So, again here we use a paper as a material, paper as a substrate material, feedstock material, and binder as a binding agent, correct. And laminated objects are often used as a aesthetic and visual models, correct. This technology is mainly used for making those components which are used as a aesthetic or visual models of some particular applications, and are not suitable for structural use. Remember, this method is not used for making an object which is used as a structural application, correct. And the most commonly used material is A4 paper and plastic sheet. Is it clear? Okay. So, let us see what are the steps we need to perform. You can see this is material spool, and with the help of this material spool you just spread. Let us say suppose you have a Suppose we have a paper like this, we just spread it, and over this paper we just provide a binder according to the exact shape of the object. You just spread it, and once you get this, then you, with the help of laser light or ultraviolet ray, we just cure it. And after curing, what we need to do, some portion of this sheet is cured over the build platform and remaining is loose, then it will move, correct. And after moving this, again we provide another layer of sheet, and again we provide some binder over the surface, over the first surface, and then again we perform curing action, and this process is repeated till the final object is produced, correct. Okay. Okay, let us see another classification of additive manufacturing process. So, additive manufacturing process can also classified in these three categories, that is liquid based, solid based and powder based, correct. In liquid based we use melting or polymerization, we also know the wet polymerization process, and in case of melting, in this category we have FDM, that is fused deposit modeling method. And in polymerization process we have SL, that is stereolithography and polyjet process, correct. So, this is the one category in which we use a liquid as a base material for 3D printing. And now we talk about solid, then loam technology, which is already discussed in the previous slide, laminated object modeling process. So, this is a solid based process in which the melting is not takes place, and another one that is powder based, and in this we have melting or binding. Is that clear? We have two categories, and in melting we use SLS, that is selective laser sintering, electron beam melting or lens, correct, laser engineered net shaping process, correct. And if we talk about binding category, here we have 3D printing, 3D printer or pro metal. So, this is the detailed classification of additive manufacturing process, you can read it one by one, correct. And let us say few important processes, I am only discussing few important processes which can be asked in your exam, correct. Okay, let us say fused deposit modeling process, already I told you little bit about this process. So, in this process we use plastic as a raw material, which is present in the form of coil, yes or no. In this process we have plastic raw material in the form of coil, yes or no, and these are the nozzles. It may be we use single nozzle or may be used double nozzle, correct. If you make a colored object, multicolor object, then you need separate different multiple nozzles, and if you make only one colored object, then you use only one object. Obviously, when you use two nozzles with same material, then its deposition rate will be higher, and if deposition rate is higher, then faster object can be easily produced. But with the help of single nozzle, you can produce the object, but at a very slow speed. It might be take suppose if you make an object whose size is 100 millimeter by 100 millimeter by 100 millimeter, then making of this object it may takes around 20 hours itself, and some machines are also available which can produce that object at a very less time, correct. So, this is the basic schematic diagram of fused deposit modeling process. Again you can see here we have a this is a build platform, or we can say this is a substrate, and over the substrate we need to deposit the material. And suppose you can see here this is the multicolor object, is it clear. So, with the help of this yellow or green wire, we provide a support material. So, first you deposit the support material. Over the deposition of support material, with the help of this main blue wire, we can deposit our object, correct. And after the completion of this deposition, you just remove that support material, and then you can get the final object. Okay. So, you can see here fused deposit modeling is an additive manufacturing technology that creates 3D model, 3D component using a continuous thermoplastic or composite material thread in a filament form. Remember, in this process we use plastic filament or a coil form, yes or no, wire form. We use thermoplastic material in the coiled form. This is very important, correct. And extruder feeds the plastic material. This is called as extruder, or this is a nozzle, and this whole setup is called as extruder, in which we have a heating coil which melts the plastic material, yes or no. So, an extruder feeds the plastic filament through an extruded nozzle which is melted and then selectively deposited layer by layer onto the build platform in a predetermined automated path, yes or no, which can be generated by obviously with the help of CAD model and 3D slicing, yes or no. So, this is extruder and this is build platform, and obviously extruder is provided in two dimensional motion, that is in a xy plane. Horizontal motion we provided and the vertical motion is provided to the build platform, yes or no. Okay. So, next you can see a stereolithography, correct, or stereolithography method, correct. And in this you can see here obviously stereolithography is a technique by using layer by layer structural fabrication, where a laser beam is focused on the free surface of a photosensitive liquid to introduce polymerization. Obviously here you can see here this is a tank in which this is a build platform, and here we have a tank which is filled with a liquid resin, and with the help of this light, laser light, we can cure according to the shape required, yes or no. This is called a stereolithography process, is it clear? And again obviously polymerization takes place and hardened surface can be made with the help of UV light or laser light, correct. Okay. Next, laminated object manufacturing, already I discussed with you, correct. In this we use paper sheet for making an object, and over the paper sheet we use a binder material, and after deposition of binder material we just cured with the help of laser light or ultraviolet rays, correct. So, already I have discussed. So, now we move in the next part, that is wire and arc additive manufacturing process. So, you can see here this is the welding robot, yes or no, and in this we use a welding torch, and especially this is a MIG welding process, correct, in which the continuous deposition takes place, yes or no. And for 3D motion we use welding robots which is having either 4 or 5 axis machine, correct. So, again if you want to make an object with the help of this process, then again you just make a CAD model, slice it, produce a steel file, then transfer to the connected to the this robotic arm, and robotic arm in robotic arm we just fit the MIG welding torch, correct, and then you just run the program, then according to the program this torch can move and deposit layer by layer the material, yes or no. So, obviously in this is called as wire and arc additive manufacturing process, and this is one of the direct energy deposition method, and in this method we use welding arc as a heat source, and electrode wire in the form of coil is used as a feedstock material, and for 3D motion generally we use either a robotic arm, or sometimes we can make 3-dimensional CNC machine, 3-dimensional CNC mechanism especially we use to move the welding torch according to the shape required, yes or no. And this process is commonly uses wire as a material source and follows a predominant path or create the desired shape, and this method of additive manufacturing is usually performed using robotic welding equipments, already I told you. And if I am talk about this process, then this is one of the best and a process which produces a very large object at a very higher deposition rate, even 10 kg per hour. This is the deposition rate which is very high as compared to other metal additive manufacturing process, correct. So, due to high deposition rate, low energy required, so this is energy efficient process and time saving process, correct, and with the help of this you can make a very large structural object also, yes or no. So, these are the few advantages of this process. Okay. So, let me see few materials. What are the materials which can be used in additive manufacturing process? So, let us see one by one. So, if we talk about biochemicals used, so in this we use silicon, calcium phosphate, zinc, while biolink fabricated form stem cells are also being explored, correct. So, if with the help of this we can also make a stem cell, which is very advanced technology, correct, and which this technology is very useful in biomechanics, correct, biofield. A range of ceramics are used in additive manufacturing including alumina, obviously alumina, tricalcium phosphate, zirconia, as well as powder glass which can be used, correct. So, listen, whenever we use ceramic material as a weld material, correct, for 3D printing, then obviously these ceramic metals are always used in the powder form, correct, because it is not used in the wire form, correct. Wire, making of wire of the ceramic metal is very difficult, it is even not possible, because it is a very hard and brittle. So, whenever we have very hard and brittle, then we use in the form of powder, you just make it and then you perform SLS process, like selective laser sintering, that is enough for making an object with the help of this material, correct. And wide variety of metals and metal alloys are used in additive manufacturing process, including gold, silver, stainless steel, titanium, and etc. So many metals are used in additive manufacturing for making a component which is used in aerospace industry, or which is used in thermal power plant, high temperature application, etc. So, we have a variety of an object which can be used, which can be manufactured by this process and used in the industrial application. Okay, next, see, thermoplastic polymers are also common. This is a very common material used in additive manufacturing, and especially it is used for making a toys or a models or a prototypes, correct, for a research purpose itself. And these includes acrylonitrile, butadiene styrene, ABS, polyacrylate, polyacetic acid, PLA, polycarbonate, as well as water soluble. Mainly we use thermoplastic material, correct, thermoplastic, not thermosetting plastic, correct. And what is thermoplastic? Thermoplastic are those material which is reusable, correct, which can be used reusable, and it can be used in a multiple times. By heating it gets softer, and by cooling it gets harder, yes or no. So, this is the basic information about thermoplastic. And if we talk about thermosetting, then this is one time usable material. When it is heated, then it gets soft, and after cooling again it get harder, then harder, and after gaining its hardness, it is not possible to again heat, make a softer by using heat. Why? Because mostly thermosettings are made by a condensation polymerization process, correct. But while as if you talk about thermoplastic, it is more mainly produced by adhesion polymerization process, correct. Okay, so this is the little bit about materials, and now where additive manufacturing technology can be used. So, aerospace is one of the extensively used field where this additive manufacturing technology is used. That is, additive manufacturing is particularly suited to aerospace application due to weight saving capability and ability to produce complex geometry. Weight saving capability, this is the one of the biggest advantage of this process, and complex geometry, and with the help of additive manufacturing process we can also make those materials which are used in very high temperature application, that is FGM, functionally gradient material, that can also produced by this process. This is one of the biggest advantage of this process. That is why this additive manufacturing technology extensively used in aerospace industry. Is it clear? And automotive, if we talk about automotives, the variety of materials are widely additive manufactured for the automotive industry, as they can be rapid prototype. Rapid prototyping, if we talk about little bit about rapid prototype, what is rapid prototype? So, rapid prototyping is nothing but, suppose this is called reverse engineering, correct. Suppose you have an object, correct, which already we have an object, and sometimes it may rupture, it may break, but we need to make again that object. So, you do not have any CAD model and etc. So, then how you can make? So, you just take it and make, or use by using scanner, you just scan it, and after scanning you can get the direct CAD model, correct. So, this is from the object we can make CAD model, and from using CAD model you can make the another object, correct. Correct. So, this is the one of the biggest advantage of this process, correct. Okay, next, medical. The medical sector is finding an increasing number of applications for additive manufacturing parts, especially for bespoke custom fitted implants and devices. This custom made implants, this and devices, these are the one of the biggest use in medical industries, correct. Okay, so let us see some important questions, few important questions from this additive manufacturing technology. So, first one, which is asked in the previous GATE exam, match the additive manufacturing techniques in column 1 with a corresponding input material. You just see here fused deposition modeling FDM, laminated object manufacturing, selective laser sintering. We already discussed about all these three processes. So, let me see fused deposit modeling, photosensitive liquid resin, heat fusion powder, filament of powder. Obviously fused deposit modeling uses filament of polymers, laminated object uses sheet of thermoplastic or green compacted metal sheet, and selective laser sintering uses photosensitive liquid resin. Yes or no? So, the correct answer is 341. 341. Okay, there is no 341. 34, yes, 34 is given here. And what about R2, selective laser sintering? Yes, in selective laser sintering we also use okay, I make a mistake. Let's see, I am going to correct it. You can see this is used filament of polymer, yes, laminated object, sheet, and selective. This is selective laser sintering, not stereolithography, correct? In stereolithography we use this, in selective laser sintering we use heat fusion powder. So, the correct answer is option A, correct? Okay. Let us see another question. Which of the following additive manufacturing techniques can be used as a wire as a feedstock material? Yes, very simple. Wire as a feedstock materials. Okay. So, stereolithography, no, in this we use liquid resin. Yes or no? Fused deposit modeling, yes, in this we use wire as a feedstock material. Selective laser sintering, in this we use powder, and direct energy deposition process, in this we can also use powder as well as wire. So, B option is correct. B option is correct, along with this D also correct. So, B and D both are correct. In both the process we use wire as a feedstock material, correct? Okay, so let us see another question. Which of the following is not subtractive process? Which of the following is not subtractive manufacturing process? So, milling is a subtractive manufacturing process. Stereolithography, this is additive manufacturing technology, this is not subtractive manufacturing. So, option B is the correct answer. Is it clear? And swaying and EDM also subtractive manufacturing process, correct? Okay, which of the following is not liquid waste rapid prototyping system, correct? So, stereolithography, obviously here we use liquid polymers. Laminated object manufacturing, in this we use sheet, not liquid, solid ground curing, and solid object ultrasonic laser printing. This is also uses liquid, this is also uses liquid. Okay, so the correct answer is okay. Okay, so the correct answer is laminated object manufacturing. Obviously, in laminated object manufacturing, we use a layer, correct? Okay, so let us see another question. Choose the correct sequence. Choose the correct sequence of generating prototype, correct? So, 3D CAD data, CAD solid modeling, STL file, rapid prototyping. Not correct answer. CAD solid modeling, 3D CAD data, rapid prototyping, STL file. Again, this is not correct. STL file, this is wrong. STL file, because our first step is to create 3D CAD model, and after that slicing, then STL file formation. So, 3D CAD data, STL file, CAD solid model, rapid prototyping. So, now which one is the correct answer? Choose the correct sequence of generate prototype: 3D CAD data, CAD solid model, STL file, and RP prototype, correct? So, this is the correct answer. Why it is correct? As we already told you, in a 3D printing, in additive manufacturing or 3D printing, our first step is to make CAD model. So this is CAD model. This is our first step. After making CAD models, we need to slice it CAD solid model, correct? 3D CAD data, then 3D CAD model we can prepare it, and after preparing 3D CAD model we slice it, and after slicing we make a STL file, and after making STL file you just make an object, 3D printing object. Is that clear? Okay, let us say another question. Process of converting STL file model is into layer is called. This is called, obviously, anyone tell me, this is called slicing. Is it clear? Slicing is the correct answer. After slicing you can make the 3D model, yes or no? Okay, let us see another question. Which of the following is not an example of additive manufacturing? Okay, once again, fuse deposition modeling, this is additive manufacturing. Electron beam machining, yes, this is wrong answer. This is wrong answer. So correct answer is option B. Which one of is following is not an example of additive manufacturing? Electron beam machining is not an additive manufacturing process. Is it clear? Additive manufacturing generally uses 1D, 2D, 2.5D and 3D. So the correct answer is 2.5D. Correct, 2.5D machine is generally used for additive manufacturing process. Okay. Which of the following is solid based rapid prototyping system? Laminated object manufacturing, paper laminated technology, electron beam melting. Which of the following is not? Remember, not correct, because laminated object manufacturing is a solid manufacturing process. Paper laminated is also a solid manufacturing. So electron beam melting, this is not a solid based rapid prototyping system. This is a liquid based, because sorry, this is a process in which the metal gets melted for deposition of the material. Yes or no? Now, which one of the following is used as a base material in the stereolithography? Obviously, thermoplastic metal powders, no. Stereolithography, thermoplastic eutectic metals, no, wrong. Photopolymers, yes, photopolymers liquid reagents are used for making a 3D component with the help of stereolithography technology. Is it clear? Okay, so this is all about additive manufacturing process. So this session is very important for you guys if you preparing for any competitive exam related to mechanical engineering, and especially for engineering services exam, GATE exam as well as ISRO exam. So this is very important session, and especially for those students who are planning for MTech and going to appear in the interview, especially in additive manufacturing, then this session is also very important for you guys, correct? So if you have any doubt regarding this session, then you just message us through in a comment section, then definitely I will reply you. Okay, thank you once again.